Okay, let's take a look at this page. Multi-dimensional scaling with R, quick R. And by the way, there's also some other stuff here that we might want to look at. Well, we've done this, but we could check. You could check it. Factor analysis is very important, but I don't think we'll get to that. Correspondence analysis. Cluster analysis, which I think we're going to be doing, and tree-based models. So some of this is interesting. Okay, anyway, so here's MDS, multi-dimensional scaling. So we have an object with n rows, just like we have, and we have p columns, right? Those are the variables, and the rows are what we call the objects. And first thing we do is we apply this function, which computes the distances between each of the rows. Remember, each row in our data set is going to be a year of movies, and we're going to calculate the distance between the years, right, which is exactly what we want. And then once we have those distances, we need, remember, this is very high dimensional data, right? We have like 1,300 columns, so we would say 1,300 dimensions. And so we need to map that onto just 2 dimensions. And so we take all of those distance data, and we have to somehow put it on a map in 2 dimensions. And that's what this does. The CDM scale will do that, and they're using a certain set of options here. And this is the data, D, but they're using this eigenvalues equals true, just one of the options. And we want to do it in 2 dimensions. Okay, you could do it in other dimensions, but since we want to see it in the plane, we'd like to do it in 2 dimensions. And then, after we do that, we want to look at the results. Okay, so that's the way it works. Now, in their data that they're doing here, it's kind of interesting. I click the result here. The plot looks like this. They're doing cars. I'm not sure exactly whether these are people's preferences or the types of cars. I mean, maybe the data is like how big the engine is and how much gas it uses and things like that, or it might be people's preferences. But I think it's more like the first one, like how big the engine is, what the price is, how much gas it uses, and so on. And then they try and find which cars are similar to each other. So we see like a Ferrari is way over here, separate from anything else, and Lotus is over here, Mercedes is up here, Cadillac, Lincoln, Chrysler, Pontiac. Maybe these are people's preferences, I don't really know. But anyway, it's kind of interesting. Maserati is way down here, so far away from everything, and Ferrari is pretty far away from everything. Anyway, it's kind of interesting. I don't know the exact data here, but it's interesting. Okay, let's go back to our code. Now remember, we had this term document matrix here, and remember what that looks like. Remember each now I think it's by year, not by film. In other words, the rows are years at this point, not films. Just like I said, we put everything into separate years. So we have all the 1974 films, all the 1975 films, and so on. So the rows are those, 1974, 1975, 1976, and so on. And then we have many, many columns for all the different words. And then they actually reduce it so that they only have the top words, right? But still we have a lot of words. I think it's still like 200 or 300 words. So it's still a lot. Okay, now the next thing we're going to do is call this function, which is basically like the distance matrix that you just saw on the web page that I just showed you, but it is so it let's see, it takes it computes the dissimilarity. So dissimilarity means how things are not similar. So in other words, the larger the number for dissimilarity, the further away things are. So it's the same idea as distance. So it computes the dissimilarity between documents in a term document matrix or between two explicit documents. So if we put in a term document matrix, we can do the distance or the dissimilarity. And so we put in x for the term document matrix, and we get out an object of class distance. So it's like I said, it's like the distance function that we saw, because it gives us back something just as the same type of thing that distance gives us. Okay, and we saw that after we did that, after we had distance, then, which we had here, then we wanted to do here, then we wanted to do the CDM scale on that. So here we create the we do a dissimilarity matrix or distance matrix. We put it in here, and then we do CDM scale on that here, and let's take a look at that function. So here it is, classical multi-dimensional scaling of data matrix, known as principal coordinates analysis. So here it is. Here's an usage, and we're going to make this true, which we don't have time to discuss it, but we need the eigenvalues, and so on. And if eigenvalue equals false, at equals false, and that equals false, a matrix with k columns whose rows give the coordinate. Okay. Anyway, see, do they give usage? Yeah, basically the same thing. So let's go back to our code. So we're going to do that, and then we're going to do something similar to what we saw on that web page here. And I think this is the labels and so on. So let's try it out and see what we get. Okay, I just ran it. Now it's supposed to create a PDF. And here's what we get. This is what we saw earlier. Actually, it's a little different, isn't it? Anyway, this is what we get. Pretty similar. Okay, so we're going to next do some cluster analysis. And there are a number of different algorithms for cluster analysis. Probably the easiest one to understand is something called k-means, which I think they talk about on this page. And we're going to be in our code using a package called, a function called PAM, and we'll talk about that in the next video.